So I am going to be talking from the perspective of a computer scientist and AI researcher. I am someone who has made a journey from probably working, starting off with very fundamental algorithmic and representational problems in AI, you know, trying to get systems that we thought from some sort of theoretical and practical point of view could do something that vaguely seemed smart. That's going to be my definition of AI for the moment. And along the way, I've sort of transitioned my own research from starting with that technical intellectual interest and focus to being more problem driven, which I guess is in some ways related to kind of the case study aspect that we've heard about. But I wanted to make a few comments about the challenges that people like me who are developing these AI systems are facing in the light of the rapid progress, the expectations of society, and some of the really hard things there are to do well in these AI systems. And I'll try and tie it back to some of the examples if I can remember the right ones. I've made a few notes. So first of all, with all the huge hype that's around, data-driven AI and machine learning and deep learning, it's worth kind of, I guess, acknowledging that in some very specific tasks that are where there is a lot of data, and I'm talking about diagnosis, classification and prediction in fairly sort of limited domains, but where there is a lot of data, that some of these AI systems just doing incredibly well. You know, the voice recognition and vision and so on, where we've got to now, are really impressive. But the problem is that just because data-driven AI machine learning system can do pretty well on recognizing faces or, detecting kind of cancers and so on and so forth, it doesn't mean that they're very good yet about making decisions. Okay, so one is knowing that something has happened, or there's some causal factor like a diagnosis or a prediction of an event. Then it's like, what do you do in a human situation? You know, what should the treatment be in a medical situation? What should the intervention be in an environmental management problem? And if there is data around about the past decisions, you usually don't want to learn from them because they're probably not the best decisions. So, and if they're one-off situations, for example, in environmental management, you don't have thousands of decisions in those cases to learn from. So that's a really big shift, I think. So from really good at some things to not good at decision-making. So I actually think that I do intelligent decision support, not automated decision-making. And that's because I'm just aware of this big gap between what the data and the models can do versus the final decisions. But I'm also aware that in a lot of the domains I'm working in, the decision makers won't accept an automated decision-making model for a medical treatment decision that involves, human life and other examples. So I think one of the interesting things is some of the examples where people have tried to roll out these automated decision-making is when it's around, high volume, possibly not huge impact, at least measured at some sort of societal level. But for an individual, it can be very high impact, hopefully not on life, but even these robo-debt, that just had huge impact on individuals. So I think that's a bit of a problem about what should be decision support versus actually handing over the decision-making. The second point on that, though, is from our point of view as technologists and developers of this, that we can say that we're developing a system that has certain performance features. And when we want to publish our research, we have to be very careful about the claims of the accuracy of our systems. There's ways in which you have to run your experiments and present your results. And, you don't claim 99% predictive accuracy or whatever the equivalent of that outrageous statement was, if you're really only getting somewhere between 80 and 85, for example. But then when we hand over that technique, possibly to startups or a model, we can't control who uses it and what they claim about it. So that is a problem about that kind of transfer of technology and models into use. In that transition as well from, a really good predictor that can say with a good probability if something's going to happen versus what we should make a decision. I wanted to also point out that when we're making decisions, and this ties into my own research area where I do this probabilistic causal modelling and decision making, that you don't just make a decision based on the highest probability thing, you know, and you don't, you know, if it's slightly more than 50% of something, you don't decide just to go ahead and do it. It depends on the consequences of that decision. And I'll give an example. This one's not quite tight. I couldn't think of one of your examples, so I've just got a standard one. You know, you've got a classifier that tells you whether something is a poisonous mushroom or not. And if it tells you with 51%, you know, 51% sure that this is not poisonous, you know, are you going to eat it? No, because the consequences of getting it wrong and dying of, you know, mushroom poisoning is too bad, you know. So it makes a big difference what the probabilities are, but it makes a difference in what those consequences are. Now, consequences of living and dying are pretty easy to capture in a model. And you can make your model very risk averse, so we can capture that technically. But in many of the sorts of systems we're talking about, it's not quite life and death, and it's around, sometimes it's a trade-off between money and other values. So when it's just money, you know, if an AI system's there helping a bank or some business work out what to do just to make a better profit, usually people aren't too worried. They want it to be right and they want to make a profit, but there's less concern. And it was interesting that those areas that you mentioned that people have particular concern about, they're the ones where what's fundamentally happening, it's not a monetary aspect. There's a value on human life or quality of life or an environmental value on losing a species and so on. And that's not a problem for us as AI modelers. That's a problem for society and the decision makers to help us build the model. So this is bringing humans in the loop during the model building as well as during the decision making to capture those values and to make those trade-offs. And I actually do that kind of modelling. And when I sit down with different stakeholders to try and, we do these expert elicitation workshops, and to get people to really be explicit about the trade-offs that they're willing to make between money and environmental value or money and quality of human life are really hard. And we don't like doing it. Sometimes you feel like reverse engineering from some past cases what people's fundamental preference models really are. But I do think that's a challenge for all of us around helping us AI modelers and builders to get it right. We have to understand what those true preferences are. And the second level of challenge for that is that there's no agreed value on a lot of these things. People from different parts of our society value different things differently. That's fine if it's just an app on my phone then, because a good AI system should be able to capture my values and preferences and offer me what I want to buy versus something else, that's fine. But when it's on government making decisions, you know, across very broadly across society, the chances of them capturing those individual subgroups' preferences and values is quite hard. And we've seen already in our broader society that there's this really fundamental, you know, difficult issues that we just don't agree on. And so the AI is not going to help us with that. I've got one more comment to make. I've got a minute or two more. Just about the explainable AI, which is a big buzzword at the moment. And I just wanted to make a couple of kind of points again about the technical challenge for us who are trying to deal with this. First of all, when the models were more simple or automated decisioning around credit scoring or even a rule-based system, it's not that hard to look at the credit scores and work out what's happening or that it would have been different if someone had been a Swedish-speaking Finn. You know, you can kind of get that out of a rule-based system or a credit scoring model. But when some of these very complex models that have been learnt now, the reason why we're building them is because there's a lot of data and the world we're modelling is really complex. And it's not clear that anyone, even the technical experts, can really look at it and understand it. So it's quite deceptive to think that if we just spend a bit more time on it, we'll somehow have this magical explainable AI from this really complex interaction of data and some really fundamentally complex model. So it's a really hard problem. What we're also trying to do though in research though is also to add, also to realise that it's not going to be just dumping text. That's not how people understand things. And if you want someone to understand an AI system, you're going to have to let them interact with it, query it. The explanation will have to be context aware of you and your background, what it's told you previously, and so on. And it will have to be multimodal. It won't just be text. It'll be a visualization, an animation, use of colour, and some text. So this, again, is a very interesting technical challenge, and some of us are working on that, but we've got a really long way to go. But I think that I'm just so sort of in I wanted to finally say that we are working on these really hard problems. I think we're making progress, but we need to be working with the decision makers, the stakeholders, the people who are going to be impacted by the use of these systems all the way along to try and capture these things in our models and to really understand as we're building it, front and centre, that this is going to be the consequences. But it's pretty hard, but it's challenging and fun. So thank you.
This podcast was part of the Re-humanising Automated Decision-Making Seminar, which took place on Thursday the 12th of December 2019. Production was by the Emerging Technologies Research Lab, which is a cross-faculty initiative through Art, Design and Architecture and Information Technology at Monash University. The event was made possible by the Re-humanising Automated Decision-Making Network, which is funded by the Riksbankens Jubileumsfond.